Hi everyone, it is your IA Natasha. Welcome to my first lecture video here on either my channel or Vimeo. It really depends on how my videos will upload. So when I send you the link, you'll figure it out if it's on YouTube or if it's on Vimeo. But this here is just like a lecture video that I have compiled for you guys. I'll be sending to you guys every week. And depending on what group you're in, you're definitely gonna either do this first for this week. And by the way, today is September 14th. So that means that if you're group A this week, you're not doing this experiment. You're gonna be in person doing lab 2. But this week, if you're group B, this is what you're gonna be watching and the lab they're gonna be doing. So depending on what group you're at, hello. But regardless, it's the videos that both all the groups are going to be using, so you get the same material. But yeah, and before I start, I want to reiterate that this is not like a specific detailed thing about the lab. You still need to read the lab. And you still need to watch the videos. So before going to this video, if you haven't done those things, I recommend you do, because then you'll know exactly what I'm talking about here. I'm really summing up the lab for you guys, and this is just more on giving you guys a visual and what you should, like what you would see in lab if this was in person. So if you haven't watched those videos yet and you haven't read through the manual, please do. And then watch this video, because then that way you won't be confused with what I'm talking about, because otherwise you'll think I'm being very vague. All right, so this lab is lab 1, recrystallization. So what is recrystallization? It's basically a purification technique. This is really important for a lab because you're going to be using this for both OChem 1 and OChem 2 labs. It's something that you're going to use all the time. Because whenever we do reactions and we're trying to get a specific compound, we want to make sure that it is pure. So a pure compound is obviously just a homogeneous sample with the same molecules, basically what you're trying to get. And that means that if they're pure compounds, then there are going to be some impurities. And impurities are basically whatever is not what the compound's supposed to be, the pure compound. So one of the most biggest impurities that we have in lab for both OChem 1 and 2 is water. Most of the time you either added too much water or you didn't dry it well enough. And sometimes it's hard because, you know, we have a limited amount of time in lab, so you're gonna have some impurities, and water is the most common one. But that's an example of an impurity for you guys. Sometimes when you're trying to cool off your compound, because you're gonna, whenever I talk more about this lab, or if you read through the lab, you're gonna know that we heat up the sample and stuff like that. If you don't take your time to cool it off, obviously, then like something like water can be trapped in the molecules in the compound whenever it's drying up, and that would be counted as an impurity. So that's just a kind of an example, not really too much of an example here, but basically you're trying to find a pure compound. You wanna get what you want. So obviously the ideal solvent is important if you read throughout the lab. It is soluble at high temperatures and insoluble in low temperatures. If you don't have the right ideal solvent, you're gonna notice that it's gonna be soluble in both high and low temperatures, and that's when you know that your compound isn't really pure and you might have to start over. So that's just something to think about. So another way for us to kind of figure out if our compound is pure is the melting point. So obviously the melting point is when the compound turns from solid to liquid. And a lot of times we like to test out our samples, finding the melting point, because we want to see how pure the compound is. Like benzoic acid, for example, for this experiment, there's going to be a specific melting point of benzoic acid. If we put our own sample and found the melting point, it's not going to be exactly the same, which is why sometimes the melting point can be tricky, because you're not going to get the exactly amount as the standard. But if you're as close to it, or depending on how close you are to the standard melting point, that's how you know if your compound is pure. So obviously, if your melting point is way farther, or if there's a huge gap between your melting point and the standard, that probably means that your compound isn't too pure. So that's just something else that we do. And then, of course, the math part of trying to find your pure compound, trying to see if it's pure or not, is percent recovery. So percent recovery, I did the math here because it's something that you guys are going to have to do for your post lab. And this is super important for literally the rest of the lab, for both labs 1 and 2, because we always want to know what your percent recovery is. You're going to see this often. But it's the amount of substance that you collected divided by the starting amount, or what you were supposed to collect depending on the experiment. And then of course we multiply by 100 because we want a percent. So once we get your percent recovery, that's when we can figure out whether or not there was impurities or if there's something happened in your experiment. And trust me, like my percent recoveries in this lab would be like 300. And I'd be like, something happened. So this is something that you're going to use a lot. Obviously, if you have a higher percent recovery, like you heard from me, like say you got a percent recovery of 100 or over, which happens, that means that there's probably something that happened in your experiment that went wrong, for sure. There's going to be a lot of impurities, or maybe your recrystallization failed. Yeah, so just make sure that this is something that you guys refer to as well. And this is also great because on your post-lab, questions, and when you go through your conclusion, talking about stuff that might happen, this is a good, you can definitely use this for that part of your lab notebook because it's proof that something may or may not happen. All right, so this is just how the lab works. This is not the specific steps or anything like that. I didn't even include trying to find the melting point because I'll talk, it's not something that we're doing in person in a way. But basically, this is just like a sum up, just to help you guys visualize what the lab kind of looks like. So yeah. So obviously, we get that benzoic acid and the amount of water depending on the solubility. And you're probably wondering when you read through that lab, how do I find that? How do I find the amount of water that I need? Which, by the way, I put just like a range right here, 15 to 20 depending. But we use the dimensional analysis, right? So here I put on top the solubility of benzoic acid. But obviously we want it's going to be a higher melting point. So we're going to use 68 grams at 95 degrees Celsius. Otherwise, you would get a really small amount of water. Or yeah, really small amount of water. But right here in the corner, we're going to start off with the amount of grams of benzoic acid that you measured first, which should be 1 grams. About from the lab's experiment, if I'm not mistaken, and the lab manual, but the amount of benzoic acid that you got, right? And then obviously we're going to divide that by 68 grams because that's the solubility right there of benzoic acid. And then it says 68 grams per liter. So we put 1 liter here, 1 liter down here. And then obviously right here, you get 1,000 milliliters. Because you're trying to find the amount of milliliters, not liters, that we need for water. And that's how you find the amount of milliliters of H2O needed, right? So once we mix everything up together, you're going to heat it up until the solid completely dissolves. And right here, I added this part right here. This is more of like during the experiment. Sometimes your solid might not dissolve well enough. So we add like 1 or 2 milliliters if needed. It wouldn't really change the experiment too much, which is why it's something that we could do, but it depends, but that's just something that we add just in case. So after you heat it up and after your solid dissolves completely in the water, you're gonna let it cool on a corkscrew right here. I drew an amazing corkscrew. And then I am going to use a glass rod to basically scratch and stir inside the beaker and basically start the crystallization. It's really cool. I believe the coordinator, Dr. Rostagi, I believe he included a video of what it looks like, but if not, definitely email me and let me know. I can definitely show y'all. It's really cool. And not only that, but I'm pretty sure in the other labs we're going to be using this technique anyway. But anyway, so you're going to stir it. Sometimes if the crystallization doesn't start, that might have mean that you might have added too much water or whatever volume of substance that you're using, and you might have to try again, which sucks. So make sure you're being really careful whenever you're trying to figure out how much water you need. Okay. And then afterwards, this is again just for the sake of the, let me move this, for the sake of what the experiment would be if it was in person, but you go ahead and you record the mass of the filter paper because you're gonna use the filter paper to start filtering the crystals, right? So you basically put the filter on top of this vacuum that we have, and then we put the crystals on the filter paper. And it's really cool because you'll see the vacuum will just like suck up most of the water, and that's what it is. It'll just be draining out the water right here in the bottom. And then afterwards, once nothing really comes out anymore, once you waited a while, you're gonna air dry it and oven dry it on a watch glass. And then afterwards, you're gonna record the mass of both the filter paper and the compound, subtract the mass of filter paper from that filter paper and compound mass, and then that's how much pure compound that you got. So that's kind of just how it looks right here. Because obviously when you're reading the lab, you're like, I don't really know what this is supposed to look like. So that's what I wanted to add here. But that's basically it. That's all I have. Again, like I told you guys, it's really much of a sum up. It's not a really detailed lecture video. It's just to help you guys visualize and understand more of how the lab works. And yeah, but please make sure you guys are going through everything. And please remember that your mock data is on tracks. Whenever you have lab that's online and not in person, you're going to be given an amount of data. So yeah, and of course, make sure that you get your pre-lab done if you are an in-person lab. But if you're online, then just make sure you do the quiz and you do the entire lab notebook for that lab before the due date, which again, all due dates and everything is on Canvas, the schedule. So please, please, please make sure you're looking at it. And yeah, that's basically it. I hope you guys have a really good day. Thank you. Let's see if I can